All right. So, good morning, everyone. Hope everybody's doing great. Everybody's all right. Sorry for running a few minutes behind. Traffic got me today. Y'all had a great weekend. So, we're going to go ahead and get into C1 today. We covered B1, 2, 3, and 4 up to this point. And we have C1 and C2 that we'll be covering. May knock all of it out before this week is out, but if not, just the next two sections that we're looking at. So looking at the rectangular coordinate system, also called Cartesian coordinate plane, those are the same thing, synonymously used. So it's made up of a vertical axis and a horizontal axis. So your horizontal axis is your x-axis, your vertical axis is your y-axis. And that breaks it up into 4 quadrants, with your origin being where they intersect. Origin, the coordinates of your origin is 0, 0. And your quadrants are going counterclockwise with quadrant 1, 2, 3, and 4. To get into your first quadrant, you have to make 2 positive moves. Second quadrant, negative, then positive. Quadrant 3, 2 negative moves, and then quadrant 4, positive, and then negative. So notice those negative and positive are split up by your origin. To the right of your origin, positive numbers. To the left of your origin, negative numbers. Above your origin, positive. Below your origin, negative. Give you a chance to copy that before we move on. Say again? All right, so when we graph or the points that we plot, we'll be using what we call ordered pairs because the order matters. So it always will be your X move first, then your Y, in other words, your horizontal, then your vertical move. Think about X comes before Y in the alphabet, or and then run and then jump, or you walk to the elevator, go down, whatever the way you want to remember it. It's always your horizontal move first, and then your vertical move. Now scroll up. Very good. So let's look at plotting a few points. You still on it? Okay, good. All right. So I would erase some of the stuff, but we'll just talk through it instead of me erasing it. All right. So let's look at graphing these points. And we'll look at the first one, 2, 5. So you always start at your origin. You always start at your origin. Remember, like I mentioned before, your X move is first and then your Y move. So if I'm starting at my origin right here, I will go to the right 2 because it's a positive 2, then up 5. And that's how we get right here. And that puts us in quadrant 1. So right 2, up 5. Those are 2 positive moves. So I should be, like I said, the right and the up are positive moves. And that'll put us in our first quadrant. The next one, -1, -3. Once again, starting at your origin. Go to the left one because it's -1, and then down 3. And that puts us in our third quadrant. -4, 2, the third point. Start at your origin. Go to the left 4 because it's negative, and then up 2. And that puts us in quadrant 2. Fourth point, once again, starting at your origin. Then it's to the right 1, but then down 5. That's +1, -5. And that puts us in quadrant 4. So questions on the first 4 points before we go to the next 2. Make sure we all right. Did the unlimited one work? Okay, good. Which, well, I'll talk to you after. Next one, 3, 0. So you start at your origin, go to the right 3, but notice Y is 0, so there's no up or down move necessary. So you just stay on the x-axis. And then for that last point, start your origin, but then you go up because there's no right move, right, X is not right. There's no horizontal move because X is 0. So you don't go right or left. You just go up 3, and that's on your y-axis. All right. Questions on those 6 points? Make sure we're okay. Because even when you graph your line, the foundation of you graphing your line is graphing these points. So make sure we're all right. Everybody good? Scrolling up. All right. So solutions of your equation. We talked about that already with just a general linear equation. So, but when we have an ordered pair, your solution is an ordered pair that when you plug into the equation is true. After you've done all your calculation, after you simplified as much as possible. All right, looking at this equation, we have 4x minus 3y equal to -2. And we want to know, is this ordered pair of 1, 2 an actual solution? So remember I mentioned before, when it comes to the ordered pair, your first component is x, the second one is y. So that means x is going to be 1 in our equation. Y is going to be 2 when we go to plug them in. And so that's what I did in this next step right here. 4 times 1 minus 3 times 2 equal to -2. 4 times 1 is 4. 3 times 2 is 6. 4 minus 6 is -2. So it means, yes, this ordered pair is a solution. So I'll give you a chance to finish that before I talk a little more about that. Right, holding on to the black up top. All right. So we're about to get into graphing lines, and this equation right here represents a line on that Cartesian coordinate plane, the rectangular coordinate system. And so when you look at graphing, there are infinitely many solutions to your linear equation. This is considered linear equations because it's going to create a line when we actually graph it. And so every point that's a solution will be a point on that line. So every ordered pair that's a solution will be a point on a line. That's what's going to make up that infinite line. That's what we're going to create. And if you haven't graphed before, haven't graphed in a while, you'll see how we generate those points. Scroll up. All right, we'll do it a couple more times to make sure we're all right. Process. Here we have y equal to 3x minus 5, and we have two ordered pairs to try. Remember, there are infinitely many solutions, so both of them could be solutions. So it is possible to have more than one solution. If I go up too far, somebody let me know, of course. All right. Using black statement. All right, cool, no problem. All right, so we have y equal to 3x minus 5. Like I said, you're going to plug in 2, 3. And then you're going to plug in 3, 4. Those are two separate order pairs. You challenge them or plug them in, substitute them in separately. So like I said, I'll pause for a second, make sure everybody's with us. Good on that last statement. Good. All right. So taking that 2, 3, remember 2 is x, 3 is y. Remember your first component is always x, second component is always y. So we plug in 2 right here, plug in 3 right here. So that's why we have 3 equal to 3 times 2 minus 5. 3 times 2 is 6, 6 minus 5 is 1. So you see 3 equal to 1. That's not true. So that means that ordered pair of 2, 3 is not a solution. So for the next one, we have 3, 4. Plug in 3 for x, 4 for y. That's 3 times 3, which is 9. 9 minus 5 is 4. So we have 4 equal to 4. And that means 3, 4 is a solution. All right, throw them up some. Very good. All right, so let's look at actually graphing these lines. Don't need that. 717. All right. So when it comes to graphing linear equations, you have three methods. And if I'm not mistaken, when you go in the web design, they'll say graph by using any method. So I'm going to show you all three. It's up to you which method you decide to gravitate to or use mostly. But we have the XY chart. All you're going to do is create an XY chart. We can use our intercepts and then we can use our slopes in order to graph. Either way, it doesn't matter which method you use, you will still get the same line. For whatever equation you're trying to graph, you'll still get the same line. That's why I say it doesn't matter which method. And as far as which method is easiest, just based upon the person who's doing it. Whatever your mindset is, if you decide doing an XY chart is the easiest, then that's going to be the easiest. And then sometimes the complexity of the equation can determine which one is easiest. But a lot of times what I find is that everybody who does whatever has made their mind up, and that method they like is the method they like. So. And it's not. All right, anybody holding on? Holding on. All right, scrolling up. So let's look at this first method, generating or creating an XY chart. Let's look at the equation of 2x plus 1. I'm going to erase some of this stuff so you can see how we started off. Yeah, let's do this. All right, so we have y equal to 2x plus 1. Notice the little statement I have up there in the orange is that WebAssign only needs 2 points. I'm always used to doing 3 because, back in my day when we used to use chisel, tablets, and stone, we did 3 points. You know what I mean? Because we didn't have the computer stuff, so we had to, do a system of checks and balances, because it takes 2 points to get a wrong line, it takes 2 points to get a right line. So at least the third one will give you a system of, okay, something is off. I had a triangle going on, right? So that's the reason I have 3 points right here. It's just a form of having, well, WebAssign, like I said, only is going to use 2 points. And so you choose those points. And it is always going to be best that you choose something small. First of all, WebAssign is only going to give you but so big of a grid. And then whatever you choose, you're going to have to graph and calculate with it. So you don't want to choose 150 and 1 million. That'd be crazy. But just remember, if you chose those three values, you're still going to get the same line, because this line goes on to infinity. And I'll show you that in a second. So once again, I've chosen -1, 0, and 1. If you want to do 1 and 2, because you don't want to do a negative number, 0 and 1, whatever the case may be. So now, whatever I choose for x, I'm going to plug in to find the corresponding y value. So for each x value, there's going to be a corresponding y value. So that'll be 2 times -1 plus 1, because notice it says y is equal to 2x plus 1. So y is equal to 2 times -1 plus 1. When x is -1, what is y? And that'll be -2 plus 1. And that's -1. And that's just a coincidence of this equation. Just because x is -1 does not mean y is always going to be -1. Or you're going to always have that repeated value like that. It's just a coincidence for this equation. Do the same thing for 0. Plug in 0 for x. 2 times 0, 0 plus 1. That's going to be +1. And then for the last value, 2 times 1 plus 1, 2 plus 1 is equal to 3. So now we have 3 points generated. Before we go to the graph, is everybody okay with how we generate those points? Once again, you choose the x values, then you have to plug them into the equation to find the corresponding y values. And that'll help you have or create your order pairs. Once you have your order pairs, you can go ahead and graph them. So once again, you start at your origin. First one is -1, so you go down 1, left 1. So that's this point right here. 0, 1, so you don't go left or right. Oh, why did I do that? Starting my order. Don't go left or right for X, but you go up 1, which is right here. And then 1, 3, go to the right 1, up 3, which is right here. And connect the dots. That will be your line. That line represents that equation graphically. Notice I have arrows going on each end. That represents they go on into infinity in those directions. So that means that if I were to have chosen, let's say, positive 20, that would have been over here, which would have gave me a point up here that still connects to this same line. Once again, still creating that same line. Or if I would have chosen -100, that would have been way over to the left, but it would have gave me a point way down here that still would have connected to the line. So once again, just re-emphasizing the fact that it doesn't matter what points you choose, but do remember that you're going to have to graph these points. So you want to choose something that's going to be on the grid that you're dealing with. Questions? Any questions? Make sure we're all right. That's the foundation of graph, whether it be a line or any equation. It's the foundation of it. You'll be able to choose some X values, plug them in, find the corresponding Y. That's a question? Yeah, for sure. Yeah. Scrolling up. All right, let's do it again, but this time let's use a fraction. Let's involve a fraction. So now whenever you have a fraction involved, you do want to be strategic in the values that you choose. Because you don't want to have to graph a decimal. You don't want to have to graph any type of fraction. You don't want to make life harder on yourself than it has to be. So if I have y equal to -3/5 x plus 2, I want to choose a value that's going to be a multiple of my denominator. Or in other words, it's a value that my denominator can divide into evenly. So in this case, since my denominator is 5, I'll choose values like 5, 10, 15, 20, 25, 30, or negative versions of that, -5, -10, -15. If it was 7, I would choose multiples of 7, 7, 14, 21, 28. If it was 11, choose multiples of 11, 11, 22, 33, 44, 55. So whenever you have a fraction, whatever that denominator is, let that be the deciding factor on what type of value you would choose. 0 is always a good one. 0 is always a good one. Anything times 0 will give you 0. So never forget that 0 is an easy one to go ahead and throw in there. So remember before I chose -1, 0, and 1. Because I have a 5 in my denominator, I'm choosing -5, 0, and 5. So instead of erasing the work, we can just go ahead and walk through it and talk through it. We have -3/5 times -5 plus 2. So what I did right here was just, treat that -5 as a fraction, putting it over 1 and multiply it across. So -3 times -5 is 15. 5 times 1 is 5. So that's how I got 15 over 5. 15 over 5 reduces down to 3. Then 3 plus 2 is 5. So when x is -5, y is +5. So make sure we're okay with that, messing with fractions before I keep scrolling up. And the questions on that first one. Next one, plugging in 0. Negative 3/5 times 0 is 0. 0 plus 2 is 2. Okay. Into that last one. Yeah, I wrote it that part down. This one, I'm gonna pull that up. Hold on a second. I did it. All right, for the last one, we're plugging in positive 5. That'll end up being negative 15 over 5 plus 2. Negative 3 plus 2 will give us negative 1. So make sure we are okay with calculating those 3 points before we graph. So finish it off. You go ahead and graph those 3 points that we have. The first one was negative 5, 5, I believe. Yep. Negative 5, 5. So start your origin. Left 5, up 5. Then we have 0, 2. So you don't go left or right for x, but you go up 2. This point right here. And last one, start your origin. You go to the right 5 and then down 1. And that's your line. Questions? Any questions? Make sure you're all right. All right. Scroll up. Very good. All right. One more with this one. It's not linear. Notice we have a power of x. I mean, power of 2 on the x. So once you start putting other powers on your x, it stops being linear. You know you're not going to have a line when you do your graphing. So this one's actually going to be a quadratic equation. But whether you recognize it, if it's linear or not, it's not the biggest deal, as long as you recognize the process. And then when you go to graph, you just operate accordingly. So in this type of scenario, they gave us these points. I think a lot of them in WebAssign, they'll give you these points. And all you do is plug them in accordingly and make sure you calculate properly. So we have y equal to 4 minus x squared. Make sure you don't lose or misplace negatives when you start doing this. Notice there's a minus sign in the equation, and the first value they give us is negative 2. So that's 4 minus negative 2 squared. So that negative 2 squared has to be applied first. So that's negative 2 times negative 2, which is positive 4. 4 minus 4 is 0. So that first point is going to be negative 2, 0. Same thing for the next one, plugging in negative 1. -1 squared is +1. 4 minus 1 is 3. Plugging in 0. 4 minus 0 is 4. And then notice when you plug in 1, plug in +2, you get the 3 and the 0 again. Make sure we're okay before we graph those points. Yeah. All right, so if we were to graph those points, and if I'm not mistaken, WebAssign gives you, I don't think they ask you to graph it, they give you like 4 options to choose from. Is this the correct graph? I think that's how they put it in WebAssign. So we would graph -2, 0. That's to the left 2, but not up or down. So that's this value right here. Then to the left 1 up 3, value right here. 0, 4, we don't move to the right or left, but we go up 1. So that's that number at the peak. That's our vertex. To the right 1 up 3, and then to the right 2, 0. That gives the other 2 points to the right. And that will give us a parabola. Questions? Make sure you're all right. Everybody good. Hold up, gotta good. Yeah, let me know. Okay. Oh yeah, so when it comes to the powers, remember I told you how that power on X, that would dictate what type of graph or equation you should get. I don't think I remember seeing y'all having a cubic one, but if you just have X, you should get a straight line. If it's X squared, you should get a U shape or parabola. It could be right side up or upside down. A cubic equation gives you more like a, I don't know what to call it, but more like a squiggly line, I guess you would call it like that. Absolute value should give you just a V, give you a straight V. So you see those lines like this on your equation on your X, and notice you're going to get a type of a V for your shape. And don't forget what the effects of the absolute value is. If I have the absolute value 5, that's 5. If I have the absolute value of -5, the answer is still 5. So absolute value gives you the positive result no matter what. So, if I have 2 minus 3, absolute value of 2 minus 3, that would be -1 on the inside of the absolute value. I can do it, right? And that would be +1 as my ultimate answer. So absolute value always, once you apply the absolute value, it always gives you a positive result. So one of those things they expect you to remember, coming in. I'll tell you a few things they expect you to hold on to coming into the class. So absolute value, that's what it does. Questions. That's really good. You don't do functions yet. I didn't know I had that at the bottom of this section. That's actually what we're going to do here. Yeah. So that's so on 849, let's do intercepts real quick, then I'll let you go. So this is still C1. Remember, I told you that there are three methods to graphing, and I was going to show you all three. So the first one was generating an XY chart. The second method are your intercepts, graphing using intercepts. So your x-intercept is where the graph intercepts or crosses the x-axis. Your y-intercept is where the graph intercepts or crosses the y-axis. There's a characteristic that holds true for all x-intercepts, and that y is always 0. And then for x-intercepts, oh, that's it, right? X-intercepts, y is always 0. Then for y-intercepts, x is always 0. Let me scroll up. All right, let me scroll up on that y-intercept. All right, so let's look at how we graph using our intercepts. So let's say if my equation is 2x plus 3y equal to 12. So it doesn't matter which intercept you decide to find first. Now keep in mind your x-intercept and y-intercepts are two different points. So you're not finding them together. You find each one of them separately. So if I decide I want to find my x-intercept first, then I'm going to start off by letting y be equal to 0. So notice we have 2x plus 3 times 0 equal to 12 because I let y be equal to 0. If that's the case, then 3 times 0 is 0. That cancels for us. That leaves me with 2x equal to 12. Divide both sides by 2. And x is equal to 6. Then for the y-intercept, you let x be equal to 0. So that's 2 times 0, which is 0. That leaves you with 3y. Divide both sides by 3. Y is equal to 4. So make sure we are okay before we move forward. All right. So those are our two ordered pairs. So your x-intercept is 6, 0, because remember y was 0. Found x to be 6, but y was 0 initially. Then my y-intercept is 0, 4, because we let x be equal to 0. And then y is 4. Mhm. Graph those 2 points, and then that's your line. Go to the right 6, or that 6, 0, and then go up 4 for that 0, 4. We'll do one more, then I'll let you guys go. But just want to emphasize the process, or re-emphasize. All right, scrolling up, very good. All right, last one for today. We have 5x minus 4y equal to 20. I'm gonna do the same thing. Find our two intercepts. Once again, it doesn't matter which one you find first. Just remember that they are two separate points and you have to find them separately. So if I'm going to find my x-intercept, I'll start off by letting y be equal to 0. So it'll be 5x minus 4 times 0 equal to 20. 4 times 0 is 0, and that leaves me with 5x equal to 20. Divide both sides by 5. X is equal to 4. All right, next one. Find your y-intercept by letting x be equal to 0. 5 times 0 is 0, so that leaves me with negative 4y. So be careful here. Make sure you don't lose that negative or that minus sign is sitting in front of 4. Sometimes people do that, so be careful. So we're left with negative 4y equal to 20. Divide both sides by negative 4, and y is equal to negative 5. So for my x-intercept, X always comes first in your order pair, then Y, so that's 4, 0. And then for my Y-intercept, 0, -5. All right, finishing it off. 4, 0 is our x-intercept, so we go to the right 4, and then 0, -5, you just go down 5 for the y-intercept, and that'll be 11. So that's a good place to stop. Next class, we'll do our vertical and horizontal lines, and then get into slopes as well. May get into C2, may not, but we'll see. Well, if you have any questions, feel free to stay back. If not, that's it for today. Make sure you get into WeberSign. I know a few people still haven't gotten in, so make sure you get into WeberSign. And if you're having any issues, make sure you get with those reps. You know, I just sent you all that information. All right. Y'all have any questions, feel free to stay back, and see you next class. Y'all have a good one. Say what now? All right, let me stop this real quick.